So I'm going to begin today's lesson by posing a completely unrelated question, completely random question, something that you knew from Algebra 1. So here's my random question. What would we have if I asked you what is 5x plus 2x? How would you do that? You know that answer. 5x plus 2x is 7x, right? We know that. Okay, and what is x? Well, x could be anything. X could be 7, or it could be 12, it could be 23, it could be negative 32, it could be 2.5, or maybe it could be root 2. What would we have if we had 5 root 2 plus 2 root 2? What would that be equal to? Well, we see the pattern directly above it. 5 times something plus 2 times that same something is 7 times that same something, right? 5x plus 2x is 7x. So if we have 5 root 2 plus 2 root 2, that's just going to be 7 root 2. 7 root 2. Now this is, I'm going to kind of box this off. All right, so we can see that that's kind of a pattern we're going to follow, but that's different than what we have up here. So we've got 5 root 2 plus 2 root 3. Well, if this was 5 root 2 plus 2 root 2, we've already got that answer. That's 7 root 2. If this had happened to be 5 root 3 plus 2 root 3, well, then that would just be 7 root 3. But it's not what it is. We've got a root 2 and a root 3. Here's how to think about this. This is just like 5x plus 2y, because that root 2 and root 3 aren't the same. So this is kind of like 5x plus 2y, and if I asked you to simplify that, you'd be like, well, Mr. Holsapple, I can't simplify that because they're not like terms. I can't combine an x and a y, right? Like we're solid on that one, right? You can't combine, you can't add or subtract an x and a y together because they're not like terms. So let's come down here to this one and see how we'd handle it. That root 2 and that root 3, they're not like terms, so we can't do anything with this at all. And this is kind of a tricky problem to start out with, but this is just going to stay the exact same because there's nothing we can do with them. We can't add them together if they're not like terms. Let's look at this next one. This one looks really tricky, except that if you look at these, the fourth root of y, those are all the same. They're all the same. This is just like an x. You could think of this as an x. So if I have 5x plus 2x minus 1x, if I have that, what's it going to be? 5 plus 2 is 7, minus 1 is 6. And I was saying x, but really we know that that x is just the fourth root of y. So let's look at this one more time. I had 5 of those things, plus 2 of those things, minus 1 of those things. So if I have 5 of them plus 2 of them and take away 1 of them, that's going to be 6 of them. 6 times the fourth root of y. So if these are the same, in the first one, when the terms were different, when the square roots were different, we couldn't do anything. We just had to say it was simplified already. In the second one, the square roots were the same, or the fourth roots were the same, so we could combine them. Let's look at this last one. Well, awesome. The square roots are different, so obviously there's nothing we can do with them, and we're just going to have to leave it here. 3 root 18 plus 2 root 50. And if you said that, I give you a high five for good thinking, okay? We just didn't execute it exactly right because there's something hidden in here, and this is really going to be the tricky part of this lesson today. Root 18, we can simplify this to root 9 times root 2. So this is 3 times root 9 times root 2. Well, we can simplify this even more because the square root of 9 is 3. And we can simplify this even more because 3 times 3 is just 9. So all of this is going to simplify to 9 root 2. Let's see what happens to the other one. Square root of 50, I know that is the square root of 25 times the square root of 2. And I know that the square root of 25 Well, that's the same thing as just 5. And I know that 2 times 5, that's the same thing as 10. And now look what we have. We have like terms. We have square root of 2. So I have 9 root 2 plus 10 root 2 is going to be 19 root 2. All right? There was like terms. They were just hiding in there. Let's do some more. 3 root 28 minus root 63. So when I'm looking at this at first, it seems like those aren't like terms, and this might be simplified. But I wonder. Root 28, I see a perfect square that I can divide that by. Root 4. This is root 4 times root 7. And the square root of 4 is just 2. And 3 times 2 is just 6. So all of that is going to simplify to 6 root 7. Okay, let's look at the square root of 63. That's going to be root 9 times root 7. And the square root of 9 is going to be 3. So what's this going to be? 6 root 7 minus 3 root 7? That's just going to be 3 root 7. Okay, let's look at these next ones. This next one is not an easy problem. Again, it seems like these are not like terms, but can we make them like terms? What's the fourth root of 32? Well, so our chart over here is not necessarily going to help us because all of those are square roots. Okay, so you're going to have to really, really think for this one. I know what this fourth, I know what goes into this one because I know that the fourth root of 16 is a perfect root. Okay, so the fourth root of 32 I can write as the fourth root of 16 times the fourth root of 2, because 16 times 2 is going to give 32, right? So what is the fourth root of 16? Well, the fourth root of 16 is just 2. 2 times 2 times 2 times 2 is going to be 16. All right, so fourth root of 16 is 2. So now 3 times 2, that's just going to be 6. So this is just going to be 6 times the fourth root of 2. And I'm going to bring that over here. 6 times the fourth root of 2. Maybe I'll drop it down and write it a little bit bigger because those fourth roots are hard to see. 6 times the fourth root of 2. That's better. Okay, now what about this next part? 5 times the fourth root of 2. Well, fourth root of 2, we can't take that down any further. So this is just 6 fourth root of 2 minus 5 fourth root of 2. So those are like terms. 6 minus 5 is just 1 times the fourth root of 2. And obviously we don't need a 1 out in front of anything. 1 times the fourth root of 2 is just fourth root of 2. So that's what we've got. Okay, you ready for this one? This one is going to be hard. Maybe it's going to be hard. Let's see. Because these are third roots, and the third root of 8 is actually 2. 2 times 2 times 2 is 8. So this is just 5 times 2. 5 times 2 is just 10. Okay, that's nice. Let's look at this next one. Third root of 27. Third root of 27 is awesome because that's just 3. 3 times 3 times 3 is 27. So this is just 2 times 3, which is just 6. Oh, this is fantastic. I wonder if they're all going to be like that. Third root of 64. Third root of 64. Great. Third root of 64 is just 4. 4 times 4 times 4 is 64. So this is just plain old 4. So we've got plus 4. Then what's this? The third root of 125, do you know what that is? Something times something again is 125? 5. That's just 5. So what we've got is 10 minus 6 plus 4 minus 5. So let's see. 10 minus 6 is 4, plus 4 is 8, minus 5 is just 3. All right, that is our answer, and that's just fantastic that it worked out so easy. That wasn't bad at all. Let's do some more. There's a lot in this lesson. Now this time what we're going to do is we're going to multiply these. Okay? So let's just multiply our numbers together and multiply our radicals together. Okay? Let's do that. 2 times 10 is just going to be 20, and root 3 times root 5 is just going to be root 15. Believe it or not, we're done. We don't have to do anything else. Root 15 I can't simplify because I can't take 15 divided by any of those perfect squares. So we've got 20 root 15. Let's look at this next one. Multiply the numbers together, multiply the radicals together. So 2 times 2 is 4. And there's different ways to think about this one. Root 9 times root 9. But I'll tell you how, let's just think about this the easy way. A square root means what number times itself is it? So root 9 times root 9 is just going to be plain old 9. Root 9 times root 9 is just plain old 9. So we've got 4 times 9 is just going to be 36. Okay, you've got this. I know you can do it. Good luck.